In this video, we're going to learn how do we solve trig equations, and we're going to go through these types of problems where we collect like terms, solve using square roots, factoring out GCF, factoring just like quadratics, and then using identities. So by now we should know if we had sine x equals a half, we would just know that the x is the angle anywhere where the sine is a half. So like pi over 6 or 5 pi over 6. In this video, we're just going to take problems that look more like this and then just get them to look like this in order for us to solve. We're definitely going to need our unit circles. All right, in our first example, we have 5 cosine x minus 3 equals 3 cosine x minus 4. And this we're going to solve by collecting like terms. It's just like any other equation that you've ever dealt with. Just get your variable on one side, numbers on the other. So by subtracting 3x from both sides, I have 2 cosine x, and I'm going to add 3 equals negative 1. Divide by 2, so cosine of x equals negative 1/2. Now we're back to something that we've seen before, and we just find any angle where the cosine or the x value is negative 1/2. This occurs at 2 pi over 3 and 4 pi over 3. So these are my answers. Next, we're going to solve by extracting square roots. So the first part is exactly the same. Just let's get secant squared by itself. That'd be secant squared x equals 4 over 3. Now here we notice that this is secant squared, so I'm going to have to take the square root of each side. And whenever we take the square root of each side, you need to remember that it's plus or minus, right? This would be 2 over the square root of 3, which is plus or minus 2 root 3 over 3. Or if you want, you can just go back to this part, and since it's secant equals that, we know that cosine of x would equal plus or minus the reciprocal of that, square root of 3 over 2. So I'm looking for anywhere where the x value would be positive or negative square root of 3 over 2. This happens at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So all of these values work in this equation. All right, here we have factoring out a GCF. Now whenever you're first looking at square root of 3, tan x, sine x equals sine x, your first instinct might be to divide through by sine x to get rid of it, but we cannot do that. If we do that, we're going to miss out on some answers. Instead, we want to start by just getting everything on one side of the equation. And we did that by just subtracting sine x. Now both of these have a greatest common factor of sine x, so I'm going to pull that out, and I'm left with square root of 3 tan x minus 1. Just like any factoring problem, now I can just set each of my factors equal to 0 and solve. And that gives me sine x is equal to 0, and tangent of x is equal to 1 over the square root of 3, or root 3 over 3. All right, so the sine of x is equal to 0 at 0 radians or pi radians. And then remember that the tan of x being equal to root 3 over 3, that comes from having 1/2 divided by square root of 3 over 2. So I'm looking for y values that are a half and x values that are square root of 3 over 2. And they can either be both positive or both negative because I need it to come out positive. That happens at pi over 6 and 7 pi over 6. All right, next we're going to factor an equation of quadratic type. You see here we have all the things are in terms of sine, but we can't just get a single sine together. So we're going to treat it just like a quadratic. I'm going to get everything on one side. And I'm going to imagine this as if it was just 2x squared minus 5x minus 3. That would factor to 2x plus 1 times x minus 3. So this factors down to 2 sine x plus 1 times sine x minus 3. This gives us the sine of x is equal to negative 1/2, and the sine of x is equal to 3. And for now, you might say, hey, there's no y values of 3 on the unit circle. We'll ignore that one for now, okay? And we'll just pay attention to this sine of x equals negative 1/2. That's going to happen at 7 pi over 6 and 11 pi over 6, since the y values there are negative 1/2. The last thing that we're going to look at is substitution using identity formulas. Here we have 2 sine squared x equals 2 plus cosine x. There's no greatest common factor. Can't really treat this like a quadratic right now. I need to get everything with a common term. So I know that sine squared x could be represented with 1 minus cosine squared x. Because of that, now I've got everything in terms of cosine. So distribute the 2. Now let's get everything on one side. The 2's are going to cancel each other, and I have 0 equals 2 cosine squared x plus cosine of x. Now I go back to my factoring out the GCF rules. Factor out a cosine x, 2 cosine x plus 1. And I'm going to look on the unit circle anywhere where the cosine of x is equal to 0 or the cosine of x is equal to negative 1/2. Those are going to occur at x equals pi over 2 and 3 pi over 2, or 2 pi over 3 and 4 pi over 3. All right, and that's solving trig equations. Goodbye.